Hello everyone, this is Rick. This week we're going to have a video of our lab since I'm unable to make it in person. So this is going to be the effective load on wind turbine output. It's going to be very similar to last time. You'll have to answer some questions, make a few graphs. It's set up just like this. You'll see here, and if I switch cameras, which I cannot do right here, I'll have to do that later. If I switch cameras, then you will see it looks just like this. I have a power sensor, I have a load sensor, which is a variable load, and I can turn it up and down. I have a fan, and we're going to do the following. I've already done all the setup and all the zeroing and calibration. So what we're going to do is I will slowly increase the resistance, and I'm not going to do two trials because I know what I'm doing. This is only in case you are not practiced in this. And I'll give you the actual resistances, and I'm just going to read them out. You're going to have to take notes yourself as we're watching, and I'll give you the power. So, and then you're going to have to answer these questions on your own and then upload it. So that's basically it, and let's get started. Okay, so I'll be calling out the data here. I'm going to give you, I'm going to be giving you a bunch of resistances and some trials. I'm not going to do the two trials. I'm just going to give you we're just going to do the average milliwatts because this was written for a student to do it. I'm confident in my measurements. So we're just going to go about 10, about 20, about 30, about 40, about 50, about 60. And then we're going to go ahead and read you the power on that. And then that will be our chart. And you'll be able to see that data also be collected here. So I'm going to go ahead and push from my device to the computer. It should start coming out now. And it does. And so here we go. Now the first data point is this first one is, we're looking at a resistance of about 11 ohms, and the power is about 39. So we'll turn that up to about 20. It won't be exactly 20. It'll be impossible to get exactly 20. So turning it up. Best we can do is 23. And our power is actually 59. And then we're going to do about 32, and the power is 67, and a little more. It's not really cooperating with me here. In real time. I'm sure it takes a while to catch up with itself. So you're not really seeing the resistance on the chart the same way I am. All right, 44 is 65.8. And up to a little more. 54 is 54. 69? I know it's, 69.9. Going up to 74. I had to skip 64, so 74 is 72.5. slightly. It's hard to get it in a nice even spot. Turning up the resistance there, won't let it go too high. So we got 88 is 66.2. Resistance of 105 is 60.9. Not really moving. It's difficult to get. There we go. 127. Since the 127 is 54. It isn't moving very responsibly. There we go. $178 is 52. That skipped up a lot. $252 is 41. I'm trying to get a number between those. It's not giving it to me. Alright, I'll turn it to full blast here. There, that's I think that's probably a true 252. We'll just have to believe the data. There's something funny going on here. Well, I think my variable load stopped reading the sensor in the middle of my run here. Alright, so let's go over what we have here. I'll show you. Hey everyone, so I had to go back and take some of that data over again. It ends up that it doesn't work as well when it's connected to my computer as it does when it's not connected, so especially with two sensors in at once, but this general curve kind of goes up and down. And I'm going to write for you the data here that I collected, and this is going to be the ohms, and this is going to be the resistance is ohms, and then the power is in watts. And this is the data that I got went back and did this one more time. Some of it's very similar. At 11, 23, 32, 44, 54, 74, 88. Unfortunately, it jumped up a lot. It was 105, 127, 178, 188, 197, 220, and 252. That's the data I had. And then we're going to look here and go, we had 39, 59, 67, 68, 69.9. Then we had 71.5, 66.2, 60.9, 54, 52, 47, 40, 33, and 3. So let's take a look here. I'm going to just circle that here, insert insert a scatter plot like this. That's kind of what our chart looks like. So you can take from this what you will. I'm not going to interpret it for you this time like I did last week. You sort of have to answer these questions by yourself. That's what it looked like. So this is low resistance, and this is why we have a load in the first place. We had more power with some resistance, and as we added more, it sort of trailed off till it got back to 0 again. And then if you look on you can fill that out here. You're going to have to put your actual data in there, and you have to sort of graph that for yourself. And you don't have to do this part. Don't calculate the average power. I'm giving you the one value because I'm confident in my results. Then you have to answer these questions here. What is it? It says, what is the internal resistance of your wind turbine? And this basic one here is it's 30 ohms on yours. The answer is 30 ohms. And it says, how does the internal resistance of your generator compare to the optimal resistance for the power output? And so it's right. You can tell they've kind of designed it to be right around the right size, so it works well. So that's that answer. And the other questions you can answer yourself, and then you don't have to do the extensions. And that's all I need from you today. Take care. Bye-bye.